Welcome to part 10.2 of my RB25 electrical build. Um, the goal of this video is to give you a bit more information on the basics of ECU wiring controls. Also, don't forget to like and subscribe. We will be covering the different types of wiring configurations, sensors and functions, ECU pinouts, and how the ECU handles power and grounds. Some cars can still be wired with an ECU or standalone ECU and still keep the stock ECU in place. Why would you want to do this is what you're asking. For one of my situations with a previous vehicle, which was my 2002 IS300 with the 1JZ, I needed the dash gauges and AC to work. These were functions controlled by the ECU and would have been dead if I went full standalone. Cool for a race car, but street car doesn't work. And also, the Lexus had an electronic throttle and electronic throttle body. This was also another complication. When you wire a car in parallel, it allows you to keep the stock ECU in place and then taps into certain wires that the standalone needs to take over in order for the engine to run. It allows all of your stock functions to work. It can be emissions friendly, and it's much simpler than doing a full standalone where the standalone takes over every little aspect of the car. The cons are the stock sensors must be used, and it's not like the worst thing in the world, but sometimes you have to figure out different resistances or even find like a graph or a table for those sensors when most of the commonly used ones already have that stuff figured out. The ECU, the stock ECU, may not play well with the standalone, and the following cons sort of set that up. So you'll have two sets of fault codes. If you have a decent standalone, you'll have that set, and then you have the OEM set. It possibly may not be emissions friendly because of all of the previously mentioned stuff. And the OEM can, of course, like I previously said, trigger limp mode with electronic throttle body cars. So this means that 3,000 RPM rev limit. So this is the video of my IS300, and let's see. Yeah, like you can see, I basically tapped into everything where the ECU sits. I either tapped in or spliced. And then the ECU itself sits on the floor. It was next to the clutch pedal. Then when you're done, you just basically tuck everything up underneath the dash.
You get to keep a lot of the good shit, such as AC, and everything on my dash works. See, voltage and all that. Not sure if the mile per gallon gauge is gonna work correctly. It's got that sticky.
But the beautiful thing about this setup was everything worked. Like really had no issues with the car. It ran flawlessly. If I could have found a way to maybe mount the ECU a little bit better, or sorry, the standalone a little bit better, I would have been a lot happier. To run it in full sequential, you will need a cam signal and a crank signal. Because of course the standalone needs to know where top dead center is, and also sort of what position in the firing order you're in. There are multiple fueling methods, but it really depends on what you're running on your engine. Speed density is good for an engine with a plenum, and this could be boosted or not. This setup will run properly if a couple of pops off, but with reduced power. So normally when you have a turbo car, and the coupler blows off and you have a mass airflow sensor, the car is done. You you may not even be able to do like 10 miles an hour. You'll have little to no throttle response. It'll just be an overall terrible experience. So that's why speed density is probably better in a bunch of situations. But as we get further down, I'll show you why mass airflow sensor also has its good points. Alpha N is good for cars that run individual throttle bodies without a plenum and without turbo plenum. This strategy only references the TPS sensor because of the low vacuum in the ITB setups or individual throttle body setups. And the best use of this is to mix this strategy with another, such as speed density or mass airflow, when you are running large cams or something like that have little vacuum and idle. Even ITB cars have very, little vacuum and idle. So mass airflow setups on plenums are typically more sensitive to changes in airflow, which is good. Way more sensitive, or not way more, but a decent amount more sensitive than a speed density car. Unlike speed density cars, a mass airflow sensor cannot monitor airflow in the plenum and will cause major problems if a coupler pops off. When a coupler pops off, the car can stumble, it can shut off. When I had my SR20, I thought the engine blew the first time it happened because I had zero power. The car would barely move. And if I took my foot off the throttle, it would shut off. If I stepped on it too hard, it would start backfiring. This can be very temperamental, especially on a car that you've turboed yourself. And not everything is perfect all the time. It can become a headache. Mass airflow can also act as a restriction once you start getting up there in power. I also had another issue with a KA that I did, a KA24DE. I had a GT35 and it had a Cobra mass airflow sensor. Probably took me a week to figure out that the mass airflow sensor cannot be close to a turbo, or else the turbulence from the turbo will cause fluctuations in the signal, which would just cause your car to run terribly, if at all. So I really don't run mass airflow sensors on any cars. I honestly don't see the point, and it's a headache. If you don't know too much about any of this stuff, I say read the Mega Manual for Mega Squirt. Even if you don't own one, it is honestly one of the best sources for information. Okay, this is my RB25 pinout. I just grabbed this from, some random website online, and I checked a few other ones to see if it was accurate. It is. I typically use this and then a few other sources, such as one for the car and then one for the ECU that was in the car, I guess. Sorry. One for the engine that's going in, especially when you're doing the swap. One for the standalone, and then one for the car that it's going into. This is my basic setup. It shows the all the different functions. It shows the RB25 pins. It has my notes. It has my Mega Squirt column, and then my MS3X column, which is for the expansion. This is the 1JZ spreadsheet I made, which has your function right here, the MS pins. So this one has MS3X and MS3. The nomenclature for the pins, and then whatever it cross-references with the Lexus ECU plug, and then the color. And then I put all the grounds down here, MS3X and then MS3. And as you can see, you have all of the connectors, like the pinouts or whatever, the actual plugs, And then I have the MS3X wiring, and then there's more up here, but it got cut out, and then there's more down here. And then finally, this is just general information. The ECU doesn't typically supply high amp or ground low amp sources. It just will cause way too much noise. So the ECU will just trigger something or cause something to fire, or however you want to put it, but it will usually not handle it itself. Injectors, different story, because they're not really high amp, but for everything else, it really doesn't have anything to do with it. It just says, hey fire, hey fire, hey fire, and that's it. Lower end ECUs usually ground the trigger for higher amperages. So you'll have like your smart coil or whatever, and then higher end ECUs can trigger higher amperage dump coils. So if you haven't noticed the pattern though, ECUs ground. Voltage, they do not supply voltage to things, they just ground it. For your inputs for your sensors, they always come in the form of pulses, or even changes. Well, I can't even say only, but you'll have pulses, like voltage pulses. You'll have like some that like generate like small voltages, and then you'll have changes in resistance. But right now we're just going to stick to pulses or changes in resistance. So you'll get pulses from your cam and crank signals, and you'll have like leading edge, trailing edge, which basically means that it's a tooth. So the first point of the tooth that strikes the thing that's generating the signal is going to be your leading edge. The part where the signal starts heading down back towards zero is going to be the trailing edge. And then you have changes in resistance, and that would be like a temperature sensor, or something like that has a sort of linear curve. But for the most part, a lot of this information can be found in the mega manual. Whatever you want to do to your car, like the basic information I'm just giving you right here, combined with the mega manual, like you will be able to wire up any car in existence, except for maybe a BMW, because it's a BMW. It's a pain in the ass. Don't forget to like, comment, subscribe. I know this is like a boring PowerPoint, but